In this lesson, you will modify a fan family for use in a power system. Click the menu browser and select Open. And from the Training Files Imperial Family Editor folder, open the file Exhaust Ventilator Downblast. From the View tab, click Thin Lines. Then from the Manage tab, click Project Units. And for discipline, select Electrical. And for current, click the Format column. And verify that the rounding is set to 1 decimal place. And click OK twice. Next, to create shared parameters, click Types. And in the Family Types dialog, under Parameters, click Add. And in the Parameter Properties dialog, click Shared Parameter, and then click Select. Then, in the Shared Parameter File Not Specified dialog, click Yes to choose a new one. And in the Edit Shared Parameters dialog, click Create. In the Create Shared Parameter File dialog, browse to a location and enter a file name, for example, Shared Parameters, and click Save. Back in the Edit Shared Parameters dialog, under Groups, click New, and for name, enter MEP, and click OK. Then under Parameters, click New, and in the Parameter Properties dialog, for name, enter Motor HP, and click OK. Then, using the same method, create additional parameters as shown. Voltage, discipline electrical, and type electrical potential. Motor FLA, discipline electrical, type current. Power, discipline electrical, type power. Phase, discipline common, type integer. Number of poles, discipline electrical, type number of poles. And next, we'll add shared parameters to the family type. In the Shared Parameters dialog, under Parameters with Motor FLA selected, click OK. And in the Parameter Properties dialog, for Group Parameter under, select Electrical Engineering, and select Type underneath that, and click OK. Back in the Family Types dialog, notice that the Motor FLA parameter is added under Electrical Engineering. Under Parameters, click Add, and in the Parameter Properties dialog, click Shared Parameter, and then click Select. And in the Shared Parameters dialog, under Parameters, select Voltage, and click OK. Then, in the Parameter Properties dialog, for Group Parameter under, select Electrical Engineering, and with the Type option selected, click OK. Then, using the same method, add the parameter Phase. Then, add number of poles. Also group it under Electrical Engineering. Then add Motor HP. But group that under Mechanical. And then add Power. Grouped under Electrical Engineering. Next, we'll create a parameter formula to calculate power. Formulas are case sensitive, so make sure that you use the same case as the name of the parameter you created. In the formula column for power, enter the following formula: voltage star motor FLA star SQRT open parentheses if open parentheses phase equal to 3, 3, 1 close parentheses, close parentheses. Next, we'll add new types to the family and change the parameters for these types. Under Family Types, click New, and for name, enter 1/6 HP, 115 V, 1 pH. Then for voltage, specify 115. For phase, specify 1. And for number of poles, specify 1. And for motor FLA, specify 4.4. And for motor HP, specify 1/6. Then, using the same method, create additional family types with the parameter values shown. You may want to pause the video at this time for each of these 3 types. Here is the first one, and here is the name and values for the second one, and here's the name and parameter values for the third one. When finished, click OK, and next we'll add an electrical connector. Click and drag the view cube as shown to spin the view. And then from the Create tab's Connectors panel, click Electrical Connector. On the options bar, select Power Balanced. Then highlight the narrow face at the base of the fan housing by using the Tab key and click to place the connector on the center of the face. Then click Modify, and next we'll map parameter values to the connector. Click Types, and with the current family type name set to the 3HP460V 3pH type, click OK, and select the electrical connector. And from the Element Properties dropdown, click Instance Properties, and for voltage, click in the equal sign field, and in the Associate Family Parameter dialog, select Voltage and click OK. Using the same method, for number of poles, select the number of poles parameter, and for apparent load, select the power parameter. Then, for load classification, select HVAC and click OK. Then, save the file as a family and name it My Exhaust Ventilator, and save it in a convenient location. Then, close the file, as that concludes this lesson. In this lesson, you will modify a variable air volume box or a VAV box with electric heat family. Click the menu browser and select Open, and from the Training Files Imperial Family Editor folder, open the file Sample Project. Then open the view 1 Power and select the VAV box shown. Then click Edit Family and click Yes to open it for editing. Then from the Family Properties panel, click Types. In the Family Types dialog, under Parameters, click Add And in the Parameter Properties dialog, under Parameter Type, select Shared Parameter, and then click Select. In the Shared Parameters dialog, click Edit. And in the Edit Shared Parameters dialog, under Parameters, click New. In the Parameter Properties dialog, for Name, type Apparent Power Phase 1. And for Discipline, select Electrical. And for Type of Parameter, select Power. And click OK. Then, using the same method, create the following 3 additional shared parameters as shown. Make sure you select Discipline Electrical and Type Power for all 3 of these. Then, create one more additional parameter, Motor On Phase, Discipline Common, and Type Integer. Then, select Apparent Power Phase 1 and click OK. Back in the Shared Parameters dialog, click OK. And back in the Parameter Properties dialog, for Group Parameter under, select Electrical Engineering, and then select Instance and click OK. Instance parameters have the word default appended to the parameter name. Using the same method, add the parameter Apparent Power Phase 2 and group it under Electrical Engineering as an instance parameter. Then, add the following shared parameters to the family type using the same method as defined in the table shown here. All of them are to be grouped under Electrical Engineering, and remember that the ones that do not show default appended in their name are type parameters, and the ones with the default appended to their name are instance parameters. Next, we'll specify formulas for parameters that we created. In the Formula column, specify the following parameters. For voltage, enter 480. For phase, enter 3. For apparent power phase 1, enter electric heat power divided by 3 plus if, open parentheses, motor on phase is equal to 1, comma, motor FLA times 277V, comma, 0 VA, close parentheses. Then, for apparent power phase 2 and 3, copy the same formula, but change the number 1 to 2 for apparent power phase 2, and change it to 3 for apparent power phase 3 as shown. In the value column, for number of poles, enter 3. For motor on phase, enter 1. For motor HP, enter 1/6. And for motor FLA, enter 1.3. Then, under Family Types, click New and type size 3 to 8 inch inlet, and in the value column, change motor HP to 1/4 and motor FLA to 2.2. Then, using the same method, create additional family types and specify the parameters for each size as shown here next. Here are the values for size 4 to 10 inch inlet. Here are the values for size 5 to 12 inch inlet. And here are the values for size 6 to 14 inch inlet. When finished, click OK. Then save the family in a convenient location. And that concludes this lesson. In this lesson, we'll place a connector and map parameters. We'll then test the family, and we'll also specify a flow configuration for the VAV, and then we'll create a supply air system. Continuing from the previous lesson, we have two files open, the parallel fan-powered VAV family file and the sample project. Let's add an electrical connector and specify its shared parameters. Use the view cube to spin the model around so you can see the controls box as shown. Then, from the Connectors panel, click Electrical Connector and highlight the large face of the controls box and click to add the connector to the face. Then click Modify and select the connector and go to its instance properties. Associate number of poles with the number of poles parameter and do the same for voltage. Then associate apparent load phase 1 with apparent power phase 1, apparent load phase 2 with apparent power phase 2, and apparent load phase 3 with apparent power phase 3. Then for load classification, select HVAC and click OK. Save the family, and next we'll test the family. Load the family into the sample project, and on the Family Already Exists dialog, click Overwrite the existing version and its parameter values. Then open the View 1 Power and select the VAV box, and on the Create Systems panel, click Power. On the System Tools panel, click Select Panel, and on the Options bar for Panel, select Panel HA. Then select the VAV box, and from the Element Properties drop-down, select Instance Properties. For electric heat power, enter 3000 and click OK. Then select Panel HA, and from the Electrical panel, click Circuits. Note that the loads on phases A, B, and C are 1360, 1000, and 1000 respectively, and click OK. Then select the VAV box and go back to its instance properties and change motor on phase to 2, and for electric heat power, enter 11,000 and click OK. Then select Panel HA and click Circuits. The loads on phases A, B, and C have updated to 3667, 4027, and 3667 respectively. Click OK, and next we'll specify flow configuration for the VAV. Click the View tab, and from the Windows panel, click the Switch Windows drop-down and select Parallel Fan-Powered VAV. Then use the View cube to spin the model around so you can see the air supply connector as shown. Select the supply air connector and go to its instance properties. And verify that Calculated is selected for flow configuration and click OK. Click Load into Project, and next we'll create a supply air system. In the View 1 Mech, in the left view, select the 4 supply air terminals using the Control key. Then On the Create Systems panel, click Supply. Then on the System Tools panel, click Select Equipment and select the VAV box. Then click Generate Layout. On the Options bar, click Settings, and for the main, verify that duct type is set to rectangular duct, mitered elbows taps, and verify that the offset is set to 9 feet. And for the branch, verify that duct type is set to rectangular duct, mitered elbows taps, and offset is 9 feet. And for flex duct type, select flex duct round, flex round, and verify that maximum flex duct length is 6 feet and click OK. Then back on the options bar, for solution type, verify that network is selected and click solution number 6. And then click Finish Layout. When you do, ductwork is created for the selected solution. Close the file without saving it, as that concludes this lesson. In this lesson, we'll modify existing electrical equipment families to create new families, and then we'll use the new families in a project. Click the menu browser and select Open. And from the Training Files Imperial Family Editor folder, open the file Lighting and Appliance Panel Board 208 MCB Surface. Select the connector and go to its instance properties. For number of poles, enter 2, and for voltage, enter 240 and click OK. Then click the menu browser and move to Save As and select Family and navigate to a location of your choice and save the family as Lighting and Appliance Panel Board 240V MCB Surface. Close the file. And next, we'll modify an existing transformer family. Click the menu browser and select Open. And from the Training Files Imperial Family Editor folder, open the file Dry Type Transformer 480-208-120V NEMA Type 2. Then on the Family Properties panel, click Types, and from the Name drop-down, select 112.5 and click Delete. Then, using the same method, while paying attention to the name, delete all of the remaining types except for 15 kVA. Then, under Electrical, for primary number of poles, enter 2, and then click Apply. Then under Family Types, click New, and for name, type 3 kVA, and click OK. For that new family type, under Dimensions, for length, enter 6.5 inches, and for height, enter 10.5 inches. And for width, enter 8 5/8 inches. Then click OK. Then save the family as Single Phase Transformer 480 Primary at a location of your choice. Then close the family. And next, we'll load the new panel and transformer families into a project. Click the menu browser and select Open. And from the Training Files, Imperial Family Editor folder, open the file Simple Room. Then, from the Electrical panel, click Electrical Equipment. And from the Model panel, click Load Family. Then, navigate to the location where you saved the new families and select them using the Control key as shown, and click Open. The new families are now loaded into the project. You can verify that the electrical families were loaded by expanding Families and then Electrical Equipment. Next, we'll test the new electrical equipment in the project. Open the view 1 Power, and from the Electrical panel, click Electrical Equipment. Note the current type and move your cursor over the wall shown and click to place it on the inside face of the wall. Then click the Change Element Type drop-down, and from under the 480V MLO type, select 125A and place it on the wall to the right of the first panel. Then change the element type to Single Phase Transformer 480V Primary 15 kVA and place that on the wall between the panels. If placement seems difficult, press the spacebar to rotate the family. Then click Modify. Next, to create a system to logically connect the panels to the transformer, select the panel board on the right as shown, and on the options bar for a distribution system, select 480/277, and then from the Element Properties drop-down, select Instance Properties. Then for panel name, enter DP and click OK. Next, we'll create a new distribution system. Click the Manage tab, and from the Project Settings panel, click the MEP Settings drop-down and select Electrical Settings. Then click Distribution Settings, and then click Add, and for name, type 480Y, and for wires, select 3, and for LL voltage, select 480, and for LG voltage, select 277 and click OK. Then click the Single Phase Transformer and go to its Instance Properties, and for Secondary Distribution System, select 120/240 single, and for panel name, type T-LC, and for distribution system, select 480Y and click OK. Then with the transformer still selected, on the Create Systems panel, click Power, and on the System Tools panel, click Select Panel, and on the Options bar for Panel, select DP, and the DP is now logically connected to the transformer. Next, select the panel board on the left as shown, and on the Options bar for Distribution System, select 120/240 single, and then from the Element Properties drop-down, select Instance Properties, and for panel name, type LC and click OK. Then click Power, and on the System Tools panel, click Select Panel, and on the Options bar for Panel, select T-LC. This creates a logical circuit between the LC panel and the transformer. Close the file without saving it, as this concludes this lesson. In this lesson, You'll modify a commercial toilet family. You'll add piping connectors to a wall-hosted toilet family and set typical connector properties for domestic cold water and sanitary systems. Click the menu browser and select Open. And from the Training Files Imperial Family Editor folder, open the file Commercial Toilet Wall Mount Flush Valve. The toilet is a wall-hosted component, and the extrusion that represents the wall is visible. But since we will be working at the back of the toilet, we must hide the wall in the view. Select the wall, and on the View control bar, click Temporary Hide Isolate, and then click Hide Element. Then, use the View cube in the upper right corner of the view with a combination of the Shift key and the right mouse button to orient the model as shown. Then, from the Connectors panel, click Pipe Connector. On the Options bar, for System Type, select Sanitary. Then, zoom in and move the cursor over the round extrusion at the back of the toilet and click to add the connector. Click Modify and select the connector. And if the arrow is pointing toward the toilet bowl, click the flip arrow so that the connector direction is pointing away from the bowl. The arrow indicates the connector direction and not the flow direction. The connector direction determines the direction from which it will accept connections from other components. Click Element Properties and change Flow Configuration to Fixture Units and Flow Direction to Out, and select Allow Slope Adjustments, and for Fixture Units enter 4, and for Radius enter 1.5 inches, and click OK. Then clear the selection, and using the same method, add a domestic cold water system piping connector at the location shown, and go to its instance properties and change flow direction to in, flow configuration to Fixture Units, and make sure Allow Slope Adjustments is cleared, and for Fixture Units enter 2.5, and for Radius enter 3/4 inch, and click OK. Then click the menu browser and move to Save As and select Family, and navigate to a location of your choice and name the family Toilet Commercial Wall Mount Flush Valve. Next, we load the toilet family into a project. Click the menu browser and select Open, and from the Training Files Imperial Family Editor folder, open the file Sample Project. Then click the View tab, and from the Windows panel, click Switch Windows and switch to the toilet family. Then click Load into Project and pack in the sample project file in the project browser under Views, Mechanical, expand Plumbing, and under Floor Plans, open the view 1 Plumbing. Then click the Home tab, and from the Plumbing and Piping panel, click Plumbing Fixture and note the current type, and then place the toilet on any wall. Then click Modify and select the toilet and right-click a pipe connector, and then click Draw Pipe and verify that the connector works as expected. Press Escape and then close the file without saving it, as that concludes this lesson. In this lesson, you will modify a light fixture tag family to include panel and circuit information. Then, you will load the revised tag into a sample project. Click the menu browser and select Open. And from the Training Files Imperial Family Editor folder, open the file Sample Project. In the project browser, under Electrical Views, Lighting, Floor Plans, open the view One Lighting. Then select the light fixture tag and click Edit Family, and then click Yes to open it for editing. Then select the One Eye label, and from the Modify panel, click Copy, and then on the Options bar, select Multiple, and copy it straight down 1/8 of an inch as shown. Then create a second copy 1/8 of an inch down from the first. Then press Escape. Then select the bottom line of the bounding box and drag it down so that the box contains all 3 labels. Then select the middle label and click Edit Label. In the Edit Label dialog, under Label Parameters, select Type Mark and click Remove Parameter from Label. Then under Category Parameters, select Panel and click Add Parameter to Label. Then, for the parameter name Panel, under the Sample Value column, type PNL and click OK. Then, using the same method, edit the bottom label and remove the type mark parameter from it and add circuit number and make the sample value read CKT. And next, we'll load the light fixture tag family into a project. Click Load into Project, and on the Family Already Exists dialog, click Overwrite the existing version and its parameter values. And the light fixture tags will update to display the panel and circuit information. Close the project file without saving it. And then also close the family file without saving it, as that concludes this lesson. In this lesson, you will create an 8-inch ceiling-hosted recessed downlight. First, we'll locate IES data file. Open Windows Explorer and navigate to the Training Files Imperial Family Editor folder and copy the file ltl9815.ies. Then browse to your Program Files RME 2010 IES folder and paste the file in this location. Then click the Revit MEP menu browser and select New Family and double-click Linear Lighting Fixture Ceiling Based. Then, from the Manage tab's Family Properties panel, click Category and Parameters and verify that the lighting fixtures parameters values are set as shown here. Then open the front elevation and select and drag the light source elevation plane to a point 4 inches above the basic ceiling and ceiling planes as shown. Then click the menu browser and select Save As Family and navigate to a location of your choice and name it 8-inch Open Downlight 42W TRT. Then from the Create tab's Forms panel, click the solid drop-down and select Revolve. Then, sketch a 4-inch horizontal line 4 inches above the light source reference plane, starting from the center to the left, as shown. Then, draw a vertical line segment down to the ceiling, and then draw a 1-inch horizontal line segment to the left. Then on the Draw panel, click Pick Lines. Then on the options bar for offset, type 1/16 inch and offset all 3 lines as shown. Use the Tab key to select the short line. Then click the Line tool, and on the options bar, clear chain and draw lines to close out the outline as shown. Then on the Edit panel, click Trim and clean up the inside corner as shown. Then, from the Draw panel, click Axis Line and sketch the axis line for the revolve as shown. Then, click Finish Revolve. Then, from the View tab, click Thin Lines and then save the family. Next, to define family and connector properties, select the yellow light source and click Light Source Definition. In the Light Source Definition dialog, for Emit from Shape, click Point, and for Light Distribution, click Photometric Web and click OK. Then, on the Family Properties panel, click Types. Then, select Calculate Coefficient of Utilization, and for Apparent Load, enter 44.21, and under Electrical, for Lamp, enter CF42TRT, and under Photometrics, change Tilt Angle to 90 degrees, and for Photometric Web File, click in the Value column, and then click Browse, and double-click LTL 9815. For Light Loss Factor, click the Value column, and in the Light Loss Factor dialog, change the value to 0.85 and click OK. For Initial Intensity, click the Value column and change the Luminous Flux value to 3200 and click OK. Then click OK, and under 3D Views, double-click View 1. Then use the View Cube to view the top of the fixture, and from the Create tab's Connectors panel, click Electrical Connector. On the options bar, select Power Balanced. Then select the face at the top of the fixture. Then click Modify and select the connector and go to its properties. For Power Factor, enter 0.95. For Apparent Load, click the equal sign column and select Apparent Load. For Voltage, enter 277. And for Load Classification, select Lighting and click OK. Then save the family. And next, to cut a hole in the ceiling, spin the model to view the bottom of the ceiling, and select the yellow light source, and on the View control bar, click Temporary Hide Isolate, and then select Hide Element. Then from the Model panel, click Opening. Then on the Draw panel, click Pick Lines, and then select the 2 arcs that make up the outside edge of the trim ring as shown. Then click Finish Opening, and on the View control bar, click Temporary Hide Isolate, and then select Reset Temporary Hide Isolate. Then save the family. And next, to test the light fixture in a project, click the menu browser and select Open, and from the Training Files Imperial Family Editor folder, open the file Simple Room, and then on the project browser, under Electrical Ceiling Plans, open the view One Ceiling Elect. Then notice the space tag, and then switch windows to the family file and load it into the project. Then go back to the electrical ceiling plan and select the 4 downlights in the room using the Control key and change them to the new family type. When you do, notice that the space tag indicates the update. Close both files, as that concludes this lesson. In this lesson, you will create a flange connector to model pipe flanges for model coordination. To create a new flange family, click the menu browser and select New Family, and double-click the template called Generic Model. Then, from the Manage tab's Family Properties panel, click Category and Parameters. Under Family Category, click Pipe Fittings, and under Family Parameters, for Part Type, select Transition and click OK. Then, save the family in a location of your choice and name it Generic 150 psi Slip Flange. Next, we'll use a lookup table file to define multiple sizes. Open Windows Explorer, and from the Training Files Imperial Family Editor folder, copy the file Generic 150 psi Slip Flange and paste it into the RME 2010 Lookup Tables folder. Next, to create family parameters, from Revit MEP's Create tab's Family Properties panel, click Types, and then click Add, and type NR. And for discipline, select Piping, and for a type of parameter, select Pipe Size, and for a group parameter under, select Dimensions, and click OK. Then click Add again, and type D1, and select Piping for discipline, and Pipe Size for type, and group it under Dimensions, and make it an instance parameter. Then create 7 more instance parameters as follows: D2 Piping Pipe Size Dimensions instance, then LEN A1 Piping Pipe Size Dimensions instance, LEN A2 and LEN A3 with the same settings, ND with the same settings, and R1 and R2 with the same settings. Then, back in the Family Types dialog, in the Value column, for NR, enter 2 inches, and under Other, for Lookup Table Name, enter Generic 150 psi Slip Flange .csv. Then click Apply, Then, in the Formula column, under Dimensions, specify the following. ND is equal to NR times 2. R1 is equal to D1 divided by 2. And R2 is equal to D2 divided by 2. And len A3 is equal to len A2 minus len A1. Click OK and save the family. Next, we'll specify lookup formulas for 4 of the parameters. Go back to the Family Types dialog and type the highlighted formulas for the 4 parameters D1, D2, len A1, and len A2. Text underscore file underscore lookup, open parentheses, quotation marks, generic 150 psi slip flange .csv, quotation marks, comma, quotation D1, quotation comma, 0 feet, comma, ND, close parentheses. The only difference is the parameter name in each formula is the same as the parameter name itself. When finished, click OK and save the family. And next, we'll define reference planes. Reference planes are used as an aid for sketching component geometry. In the View Floor Plans Ref Level, on the View control bar, change the scale to 3 inch equals a foot. And from the Datum panel, click the Reference Plane drop-down and select Pick Existing Line or Edge and change the offset to 2 inches and click to the right of the center reference plane and then click again to its left. Then press Escape and select the left plane and go to its element properties. Then for name, type pipe and click OK. Using the same method, name the right plane connector. Then on the Detail tab's Dimension panel, click Aligned and create 2 dimensions as shown. Then select the dimension on the right and from the Label drop-down on the Options bar, select len A1. Using the same method, select the other dimension and assign the label to len A2. Then select the horizontal reference plane and the 3 vertical reference planes. Then click Element Properties and under Other, for Is Reference, select Not a Reference. Then click OK and save the family. Next, we'll define geometry. From the View tab, click Visibility and Appearance, and on the Model Categories tab, click Object Styles. Then set the projection line weight for each category to 5. And click OK twice. Then from the Create tab, click Model Line and draw a vertical line as shown on both the left and right vertical reference planes. The length is not important, but that they are sketched on the reference planes. Then draw a horizontal line on the horizontal reference plane between the intersections with the left and right reference planes as shown. Then click Modify and select the 3 model lines and click Visibility Settings. In the Family Element Visibility Settings dialog, under Detail Levels, Clear, Fine, and click OK. Then click Instance Properties and for Reference, select Not a Reference and click OK. Then from the Detail tab, click Aligned and move the cursor over an endpoint on the left vertical line and press Tab to highlight the endpoint and then click to select it and then select the horizontal reference plane and then move down and click the other endpoint, and then move the cursor to the left and click to place the dimensions. Then click EQ. Then do the same thing for the right side. Then create dimensions for the overall length of each vertical line as shown. Then select the overall dimension on the left, and on the options bar for label, select D2. Then select the dimension on the right and set the label to D1. Then save the family. And next we'll create the first extrusion of the flange. Open the left elevation view, and from the Create tab, click the solid drop down and select Extrusion. Go back to the Create tab and click Set Work Plane and specify the work plane pipe and click OK. Then click the Create Extrusion tab, and from the Draw panel, click Circle. Then on the options bar, click Radius and enter 5 inches. Click the intersection of the horizontal and vertical reference planes. Select the circle, zoom out if you can't see the dimension symbol, and click on it, and then select the dimension line, and on the options bar for label, select R2. Clear the selection, click the element panel drop down and select extrusion properties. For extrusion end, click the equal sign column, select len A2 and click OK. For visibility graphics overrides, click edit and then clear coarse and medium and click OK twice. Click Finish Extrusion. Then save the family. Next, we'll create the second extrusion for the flange. From the solid drop-down, click Extrusion, and then go back to the Create tab and click Set Work Plane. Specify the reference plane center or left-right, and click OK. And then click the Create Extrusion tab, and from the Draw panel, click Circle, and on the options bar, click Radius and set the radius to 10 inches. Click the intersection of the two reference planes. Select the circle and click the icon for Make this temporary dimension permanent, and then select that dimension, and for label, select R1. From the element panel drop-down, select Extrusion Properties, and for extrusion end, click the equal sign column and then select len A1 and click OK. Then click Edit for visibility and graphics and verify that coarse and medium are cleared, and click OK twice and then click Finish Extrusion. Save the family. And next we'll add connectors and define properties. Open the 3D view, View 1, and on the View control bar, click the scale and select 6 inch equals a foot. Then back on the View control bar, click Model Graphics Style and select Wireframe. Using the Shift key and your right mouse button, spin the view so you can see both extrusions. And then from the Connectors panel, click Pipe Connector. On the options bar for System Type, select Fitting, and then highlight and click the large diameter face of the flange where the two extrusions meet. Select the connector, and if necessary, flip the arrow for the direction of the flow, and then click Element Properties. Change the radius to 5 inches. Click OK. Using the same method, create a connector to the larger extrusion. If necessary, change the direction of the arrow. It should be pointing to the direction of the smaller radius Then select the first connector, and from the Connector Links panel, click Link Connectors, and then select the second connector. Using the Control key, select both connectors, and go to the Instance Properties dialog, and for radius, click the equal sign column, and then select NR, and click OK twice. Save the family. And next, we'll test the flange in a project. Click the menu Browser, and select Open, and from the Training Files Imperial Family Editor folder, open the file Simple Room. Then in the Project Browser, under Mechanical HVAC Ceiling Plans, open the View 1 Ceiling Mech. Then switch windows to the Flange family, and then click Load into Project. Then click the Home tab, and from Plumbing and Piping, click Pipe. Then draw a length of pipe. Click Pipe Fitting, and insert the flange at the end of the pipe. Click Modify, and close the file without saving it. Then close the family file as well, as that concludes this lesson. In this lesson, you'll create an elbow pipe fitting family. Click the menu Browser and select New Family, and double-click Generic Model. Click Category and Parameters, and under Family Category, select Pipe Fittings, and confirm the settings, and click OK. Then save the family in a convenient location, and name it Threaded Generic Elbow. Then change the scale to 6 inches equals a foot. Then click Reference Plane, and on the options bar, change the offset to -1 inch. Then click the vertical reference plane to draw a reference plane to the left of it. Then press Escape twice, and select the reference plane, and name it Fitting. Then, using the same method, add another reference plane 2 inches to the left of the new reference plane. Name that reference plane Coupling. Add a new reference plane, a horizontal one, 2 inches above the horizontal reference plane. Name that reference plane Radius, and then save the family. Next, from the Datum panel, click Reference Line, then draw a horizontal line of the approximate length and location as shown. Then from the Modify tab, click Align, then click the middle vertical reference plane, and then click the right end of the reference line, and then click Lock. Select the left vertical reference plane, and then click the left end of the reference line, and click Lock. Click the bottom reference plane, and then select the reference line, and click Lock. Draw another reference line with the approximate length and location shown. Align and lock its left end to the left vertical reference plane, and then align and lock it to the bottom reference plane. From the Create tab's Datum panel, click the reference line drop-down and select Draw by Arc from Center and Endpoints. Click the intersection point shown, and then click the endpoint shown, and then move to the right and type 45. Press Escape twice and select the arc reference line. Zoom out until you can view two dimension controls, and click the dimension control on the lower right of the arc that controls the overall dimension, and click it to make that temporary dimension permanent. Zoom back in and drag that temporary dimension away from the arc as shown. Clear the selection. Using the reference line tool, draw a diagonal reference line at a 45-degree angle from the right end of the arced reference line, approximately as shown. Press Escape twice and select it, and convert the temporary dimension for the overall length to permanent. Drag that permanent dimension over to the right to move it out of the way. From the Detail tab's Dimension panel, click Aligned and draw the three dimensions shown. Then, from the Dimension panel, click Angular and add the dimension shown. Then, save the family. Let's create family parameters and assign them to dimensions. From the Family Properties panel, click Types, then under Parameters, click Add, and type len A1. And for Discipline, select Piping. And for Type, select Pipe Size. And for Group Parameter under, select Dimensions. And then select Instance to create this as an instance parameter and click OK. Then create a second parameter named len A2 with the same settings: piping, pipe size, grouped under dimensions as an instance parameter. And then create the third one and name it BDY rad with the same settings: piping, pipe size, grouped under dimensions as an instance parameter. Create another one called CPL rad, again with the same settings: piping, pipe size, grouped under dimensions as an instance parameter. The next one will be called NOMDIA with the same settings: piping, pipe size, grouped under dimensions as an instance parameter. The next one will be called NOM rad with the same settings: piping, pipe size, grouped under dimensions, and created as an instance parameter. The next one will be called ANG, and this one will be under the Common discipline with the type set to angle and grouped under dimensions as an instance parameter. Then for CPL rad, enter the value 1.25 inches, and for NOM RAD, enter the value 2 inches, and for LEN A2, enter the formula LEN A1 times the tangent of ANG divided by 2. For NOM DIA, enter the formula NOM RAD times 2, then click OK. Then select the vertical dimension on the left, and on the options bar for label, select LEN A1. Label the left horizontal dimension LEN A1 and the right horizontal dimension LEN A2, and the angular dimension on the right ANG, and the angular dimension on the bottom also ANG, and the remaining dimension LEN A1. Then save the family. Next, we'll use a lookup table file to define multiple sizes. Open Windows Explorer and navigate to the Training Files Imperial Family Editor folder and copy the threaded generic elbow file and paste it to RME 2010's Lookup Tables folder. Then go to Revit MEP's Family Types dialog, and for Lookup Table Name, in the Value column, type threaded generic elbow.csv. Then for LEN A1, in the Formula column, enter text underscore file underscore lookup, open parenthesis, quote, threaded generic elbow dot CSV, quote, comma, space, quote, LEN A1, quote, comma, 0, comma, NOMDIA, close parenthesis. Then for CPL RAD, enter the same formula, but change the parameter LEN A1 to CPL RAD. Then do the same for BDY RAD. Then click OK and save the family. Notice that each formula is applied and the dimensions are adjusted. Next, we'll create a fitting profile. The fitting profile will provide a geometrical shape for the sweep extrusion, and the sweep will use the profile and the reference lines to create the elbow fitting geometry. Click the menu browser and select New Family, and double-click the template file called Profile. Then, from the Detail panel, click Line. Then on the Draw panel, click Circle, and draw a circle with any radius in the approximate location shown. Then, select the circle and go to its properties and click Center Mark Visible and click OK. The center mark will allow you to align the circle to the reference planes. From the Modify tab, click Align. Then select the horizontal reference plane and then the horizontal center mark, and then lock that alignment and repeat the alignment vertically. Then select the circle and make its dimension permanent and click the dimension value and change it to 1 inch. Then change the scale to 6 inches equal a foot. Then zoom into the sketch and then open the Family Types dialog. Add a parameter called RAD, and for discipline select piping, and for type select pipe size, and for group parameter under select dimensions and click OK. Then under Family Types click New and type Fitting and click OK. Then create a new family type called Coupling. Then close the Family Types dialog and select the dimension, and for label select RAD. Then click the menu browser and go to Save As, Family, and after browsing to a convenient location, name it Threaded Pipe Profile and click Save. Next, to load the Threaded Pipe Profile into the Threaded Generic Elbow family, click load into project. Then, in the threaded generic elbow project browser, expand Families, Profiles, Threaded Pipe Profile, and right-click Coupling and click Properties. Then, for RAD, click in the equal sign column and select CPL RAD and click OK. Then, click Apply, and for Type, select Fitting, and for RAD, click in the equal sign column and select BDY RAD and click OK twice and save the family. Next, we'll create sweeps using reference lines. Select everything in the drawing area by dragging from right to left as shown, and then click Filter and Clear Reference Lines and Reference Planes and click OK. Then on the View control bar, click Temporary Hide Isolate and click Hide Element. Then from the Solid drop-down, click Sweep. Then from the Mode panel, click Pick Path. Then select the horizontal reference line shown and then click Finish Path. Then click Element Properties, and for Profile, select Threaded Pipe Profile Coupling and click OK, and then click Finish Sweep. Then clear the selection and go back to the Solid drop-down and select Sweep and click Pick Path and select the arced reference line shown. Then click Finish Path and then click Element Properties, and for Profile, select Threaded Pipe Profile Fitting and click OK and Finish Sweep. Then, using the same method, create the geometry for the right coupling. Then save the family. And next, to verify the fitting geometry, open the 3D view, View 1, and from the View tab, click Visibility and Appearance, and from the Annotation Categories tab, clear Show Annotation Categories in this view, and click OK. Then, using the View cube, view the different sides of the fitting geometry to verify it. Next, we'll create detail level geometry. Open the Ref Level view, select everything in the drawing, and click Filter. Then click Check None, and then select Other, and click OK. Then, with the 3 sweeps selected, on the View control bar, click Temporary Hide Isolate, and then click Hide Element. Then from the Create tab, click Model Line. Then on the Draw panel, click Pick Lines and select the left horizontal reference line shown. Then click Lock and then select the arced reference line and click Lock. Then select the arced model line and zoom out to see and select its lower right temp dimension to make it permanent. Then select the permanent dimension, and from the label drop-down, select A and G. Then relocate the dimension line as shown. Then clear the selection, and using the previous method, create a model line by using the diagonal reference line. This time, do not lock the diagonal model line to prevent over-constraining the sketch. Click Modify and select the diagonal model line and convert its overall temporary dimension to permanent, and then label that dimension to the family parameter LENA1. Next, from the Detail tab's Dimension panel, click Aligned, and then click Angular. Select the diagonal model line, and then the horizontal reference plane shown, and then place the dimension as shown. Click Modify, and relocate the dimension annotations and modify the witness lines as shown. On the View control bar, click Temporary Hide Isolate, and then click Reset Temporary Hide Isolate. Then save the family. And next, we will flex the part to validate the design. This is done by adjusting the parameter values to make sure that the reference planes to which you applied the parameter change accordingly. From the Family Properties panel, click Types, and for the parameter A and G, type 90. Then click OK. When you do, the part should flex and become a 90-degree elbow fitting. Change the A and G parameter value back to 45. Next, we'll add tick marks and dimension them. Select everything and click Filter and Clear Lines and Reference Planes and click OK. Then on the View control bar, click Temporary Hide Isolate and click Hide Element. From the Create tab, click Model Line, and at the left end of the fitting, draw a vertical model line approximately as shown. Then, at the right end of the fitting, draw another model line that's perpendicular and tangent to the end of the diagonal model line with approximate length as shown. Then, from the Detail tab, click Aligned. Then, click the horizontal reference plane shown, and then the top end of the model line, and place that dimension. Then, dimension the bottom half similarly. Then, using the same method, dimension both halves of the right model line by clicking the diagonal model line first, as shown. Then, click Modify and select the lower dimension for the left model line, and on the options bar for label, select CPL RAD. Using the same method, associate the other three model line dimensions to the CPL RAD parameter. Then clear the selection, and from the Detail tab, click Aligned, then click Angular, then click the diagonal model line, and then click the right model line tick mark, and move the cursor down and place the dimension. Then click Modify and select the angular dimension and zoom out to see its lock icon and lock it to 90 degrees. Then on the View control bar, click Temporary Hide Isolate, and then click Reset Temporary Hide Isolate. Then save the family. Next, we'll specify object visibility to determine the type of elbow fitting geometry that displays for each detail level setting. Select everything in the drawing and click Filter, and then click Check None, and then select Lines and click OK. Then click Visibility Settings, and then clear Fine and click OK. Then select everything again, and then click Filter, and this time click Check None, and then select Other and click OK. Then click Visibility Settings, and then clear Coarse and Medium and click OK. Then save the family. Next, we'll add connectors. Open the 3D view, View 1. Use the View cube to view the faces at the ends of the fitting. From the Create tab, click Pipe Connector, and on the options bar for System Type, select Fitting, and then select the edge of the right face of the fitting. This is the primary connector, and you place the primary connector on the right face because this face is on the x-axis. Next, place a connector on the left face of the fitting. Click Modify, and next we will link both connectors. Select the primary connector, click Link Connectors, and then select the other connector. Next, to specify connector properties, select the two connectors and then click Element Properties, and for angle, click in the equal sign column and select A and G and click OK. For radius, click the equal sign column and select NOMRAD and click OK. Click OK again, then save the family. And next, we'll test the elbow fitting in a project. On the menu browser, click New Project and click OK. Switch windows to the threaded generic elbow family and click Load into Project. Select Project 1 and click OK. Then click the Home tab, and from the Plumbing and Piping panel, click Pipe, and then click Element Properties, and then click Edit Type. For elbow, select Threaded Generic Elbow and click OK twice. Then on the options bar for diameter, select 3 inches. Draw some piping using various angles and offset elevations. Click Modify. On the View control bar, for Detail Level, click Coarse, Medium, and Fine to see how the new elbow fitting geometry displays in both floor plan and 3D views. To check connectivity, place the cursor over the piping and press Tab, and the piping highlights, indicating that it is connected. Next, we'll hide shape handles. Open the View 1 mech and select an elbow from your test piping layout. If necessary, from the View tab, click Thin Lines. Notice that triangular and dot shape handles display on the elbow along with the two connectors. These need to be hidden. Click the View tab and then click Switch Windows and select Threaded Generic Elbow Floor Plan Ref Level. Then select everything in the drawing and then click Filter and click Check None and select Reference Planes and click OK. Click Element Properties, and for Is Reference, select Not a Reference and click OK. Save the family and then click Load into Family. Then with Project 1 selected, click OK and click Overwrite the existing version. Select an elbow and notice that all shape handles are hidden. Close the test project without saving it, and then close all other files. And that concludes this lesson. In this lesson, we'll create an annotation symbol family. Click the menu browser and select New Family, And in the Imperial Templates folder, open the Annotations folder and double-click Generic Annotation. Then zoom in to view the note, which contains key points to remember when creating an annotation family. Then select the note and delete it. And next, we will draw lines to create the basis of the annotation symbol. From the Detail panel, click Line, then zoom into and click the intersection of the two reference planes, and then move to the right and type 1/8 of an inch. Then, using the same method, draw 3 more lines, 1/8 of an inch long, above, below, and to the left of the intersection, as shown. Then click Modify, and using the Control key, select both of the reference planes, and on the View control bar, click Temporary Hide Isolate, and click Hide Element. Next, we'll create the filled regions for the annotation symbol. Click the View tab, and then click Thin Lines, and then go back to the Create tab, and select Filled Region from the Detail panel. Then on the Draw panel, click Center Ends Arc, and on the Options bar, click Radius, and then type 3/32 of an inch. Click the intersection of the 4 lines. Click the top end of the upper vertical line. Click the endpoint on the right side for the horizontal line on the right. Then on the Draw panel, click Line, and on the Options bar, select Chain. Then click the upper end of the arced line. Then click the intersection of the 4 lines. Click the lower end of the arced line. Click Finish Region. Using the same method, draw a filled region on the opposite lower left quadrant. When finished, from the Create tab, click Line, and on the Draw panel, click Circle. Then on the Options bar, select Radius, and then verify that the value is 3/32 of an inch. And then click the intersection of the 4 lines, and click Modify. Click the menu browser, and select Save As Family. And after specifying a location of your choice, name the family New to Existing, and click Save. Next, we'll test the annotation symbol in a project. Click the menu browser and select Open, and from the Training Files Imperial Family Editor folder, open the file Sample Project. Switch windows to the New to Existing family, and then click Load into Project. Click the Annotate tab, and from the Detail panel, click Symbol, and on the Place Symbol tab, select Type Properties, and for Leader Arrowhead, select Arrow Filled 15 degree, and click OK. Then on the Options bar, change the number of leaders, and then zoom in and place the annotation symbol in the project, and press Escape twice. Select the leader to display the shape handles, and drag the middle shape handle to modify the middle of the leader, and drag the end shape handle to modify the annotation symbol as shown, and drag the cross arrows to relocate the symbol. Close the file without saving it, and then close the family file, and that concludes this lesson.